And so Rhian's talk is going to attempt to demystify the world of dApps, or decentralized applications. So can we have another warm welcome for Rhian Lewis?
So, how many people in the audience, apart from Giselle, are developers or ex-developers? Okay, you might as well leave now because you'll find this very, very basic and dull. It's a talk for non-techies. I'm joking, you don't have to leave now, but just try not to fall asleep. So we hear a lot about this idea of Web 3.0, of our new decentralized future. But just like with the words blockchain technology itself, people tend to trot them out without really thinking about how these things work. Like we're used to the idea of how a website works. In approximate terms, we know roughly how our social media apps work, but people will just talk collectively. And I hate this idea of using the word blockchain as a kind of this huge noun that encompasses everything. I tend to say blockchain technology because it's not a miracle cure. It can do amazing things, but in order to understand the amazing things that it can do, we need to dig a little deeper into the specifics of how these applications work. So this isn't an intro to how blockchains themselves work. It's the idea of things that you might create on top of blockchains and how they work with the technology underneath. So first of all, let's have a think about why we want to learn about this stuff. So Giselle gave some pretty compelling philosophical reasons about why blockchains are so important. And I've always been drawn to the idea of this censorship-proof quality that blockchains have, being able to send payments that are independent of third parties, being able to interact with people without the need of third parties, and so on. So there are really interesting ideas around why we might want to use blockchain technology. But the next slide, which we'll see in just a moment, it illustrates the extent to which big corporates are using this technology and investigating it. So you don't have to necessarily. I think everybody should be able to use Bitcoin and cryptocurrencies. I make no secret of this. Since the moment I first read about Bitcoin, I was fascinated by it. And that's why I started my meetup group with my friend, which is at Skills Matter. But you don't have to use a cryptocurrency wallet to experience the applications of the future that are being built by corporations as we speak. I'm going to just ask you to imagine this slide, which is supposed to be here now, which shows logos from people like Goldman Sachs, American Express, Visa, but not just financial companies, IBM. IBM actually have 1,500 people at least working on blockchain initiatives within their organization. If you work in technology, you're familiar with the idea that Amazon, through Amazon Web Services, are where many applications across the world are hosted, and AWS offer blockchain solutions out of the box. Away from the headlines, which concentrate on the price of particular tokens, there is actually a lot of tech happening in the background. And I think that's really the message as to why we should be interested in it. So I'm just trying to remember my slides, and then we're going to have to sort of click through them super quickly when we get them. I was just going to say a little bit. I mean, Giselle did a really good job of explaining the basic principles about why you might want to use this technology. And the takeaway really is The Economist summarised it very well in a cover that they had a couple of years ago called The Trust Machine. So it's the immutable nature of blockchains, the fact that you cannot delete from them, which makes them such a powerful tool for building applications on top of. Because I'm going to draw a distinction now between private and public blockchains, because most of the time when people talk about our decentralized future, they're doing it in the context of public blockchains, which is open source software that anyone in the world can download and are incentivized to be the record keepers, so that we have, rather like the analogy that I always like to use is that if you have a village bowls or gardening society that everybody pays money into, and the treasurer keeps an Excel spreadsheet on their computer at home, you have to really trust that person. Whereas if you have everyone in the society who has access to even a Google spreadsheet, not a blockchain, everybody can see the records that are there. They can see if anyone is entering fraudulent transactions. And while you have to be really careful to draw a distinction between something like a Google spreadsheet, which is obviously a centralized thing, and a decentralized thing like a public blockchain, that is the crux of it. This ability of people to be able to see transactions and know that those transactions cannot be reversed or overwritten. So there's been this trend recently, rather like in the very early days of the internet. Large companies are quite conservative in their approach. So just like in the very early days of the internet, when people couldn't really see the value of having this big public network and having a presence there, and it became a fashion for a little while to have intranets where they could build a wall around their content so that only particular people could see it. We can think of private blockchain implementations rather like this, but what this means is that you don't reap the full benefits, the full trust benefits that you get with a public blockchain. What you get is essentially a slow database. There are kind of some advantages, because you can prove that within the small number of signatories and people who have permission to access it, that certain things have happened at a certain time. But what you gain in convenience for being able to apply your old business model and have this kind of permissioned system, you lose in terms of this kind of dramatic game-changing scope that the public blockchains offer. So I wanted to draw this distinction before I talk about one example of where blockchain technology might be useful. Admittedly, this is in a permissioned sense, but in quite a large permissioned sense. I mean, how many people in this room have heard of Ethereum? Okay, cool. You see, even this in itself is a huge advance. If I was doing this talk a year ago, people would just have looked blank. Maybe people in the audience would know about Bitcoin. Brilliant. And this has opened on exactly the slide I wanted. So that's a miracle. So we won't go back to the slide where we show all the logos of companies, but it's more a question of which companies are not on it. I'm completely losing track of time, and I once overran a 4-hour blockchain workshop. So people have to shout at me if I start running out of time, but I'll try to estimate the time I've got left. So shipping is a great example. And in fact, there is already a solution which has been part developed by Samsung, which is operational. The first blockchain-powered shipment in the world has already occurred. So why might we want a blockchain solution for shipping? An average container ship coming from China to Europe can generate an amazing 2 kilograms of paperwork. And if you think of every sheet of paper representing hours of people's time filling this out, so that you have these pieces of paper that are countersigned, photocopied, passed around and kept on the ship as bills of lading and customs declarations and so on. The idea that this could be done automatically in a way people trust without this 2 kilograms of paperwork and hundreds, perhaps thousands of hours of people's labour, it's a really compelling idea. But if the participants in this whole shipping process trusted each other, it would not be necessary. But the point is that companies don't trust companies. So you have a container that says it's full of goods which are genuine and not counterfeit. And company A has to trust that that is in fact true. Countries don't trust companies to bring in products that comply with local laws and regulations. And then, simply, countries don't trust other countries to enforce this at the point of departure. So this is why this idea of an immutable ledger that is trusted by all parties that have access to it and cannot be gamed in any way is such an interesting idea. So I've spent a little while just explaining why people might want to use this as a solution, because as Giselle said, there are lots of trade-offs. You can imagine that the idea of a smart contract on something like the Ethereum network, where the same contract has to be executed by thousands of computers, is much, much, much slower. There's always this huge trade-off between speed and trust. I'm not going to talk people through this. This is what a smart contract in Ethereum looks like. It's surprisingly simple because the language that Ethereum uses natively, you can actually write contracts in other languages and compile them, but the language that smart contracts are written in natively is called Solidity. And it is very limited language. So this actually looks a lot less complicated than something that you might find even on the most basic website. Just showing you that to give people an idea that when we talk about building a decentralized application, writing a smart contract, this is the sort of thing that you might see. But of course, a smart contract is no good on its own. Just like an HTML page is not a website. You can have an HTML page, you have it on your local machine. It's not a website. People can't see it. It doesn't interact with anything. Say you have an e-commerce site, you can write an HTML page, but unless it is pulling in data and displaying the things you want it to display, it is useless. So a blockchain and a smart contract do not exist in a vacuum. In order to make this work, we need to allow people or possibly other applications the ability to access the blockchain data that lies underneath it. And this is why we would build an application on top. So say, for example, you have a healthcare application that shows you in a digital ledger who has accessed your health records. You need, in between what you see on your phone or on the website, you need some layers that interface with the blockchain in order to access that data. So we write DApp in a rather fancy way, like this, with a small d, capital A, just to indicate that it's like a normal app, but decentralized. But some dApps are more decentralized than others, as I will attempt to show you. So, excuse that very badly drawn thing that I did on my kitchen table at home. This is for the non-developers out there. I'm sure a lot of you probably work in relatively technical surroundings, or the fact that you're here at this meetup tonight probably signifies that this is something that you're going to be aware of. But in most cases, you have a website, you have a mobile app, you have some kind of data structure underneath. I've put DB for database. It might not necessarily be a database. It could just be an in-memory store. It could be a JSON file. It could be or it could be like a full-on traditional relational database. But in order to get the data out of the back end and into the front end, we often use what's called an API. I told the developers here they were going to be very bored by now. So for people who want to understand exactly what this term is, especially if you work on a project and your development team are always talking about problems with the API, it's the best analogy I've ever heard for this. It's like a menu in a restaurant. You cannot walk into a restaurant and say, well, unless you're a really fussy eater, you can't say, I want an apple, 4 ounces of double cream, a slice of chicken and some lentils. You have a menu that allows you to access what you want in a structured way. And that's exactly what an API does. It's like putting goods on display in a shop. It allows you to also to restrict data that you might not want people to see. And it just presents this data in an organized way. And this, unfortunately, is the crunch point where people tend to claim that they are building a decentralized application because they are using Ethereum underneath. But they might be diverting all the data through a centralized API which they have developed themselves, which they have hosted themselves, which they are drawing a subset of data from the Ethereum, or I keep using Ethereum as an example. There are many other public blockchains, but because Ethereum's the best known smart contract vehicle, I keep using this as an example. So be wary of people who say, I have built a decentralized application and there is a private API underneath it that they could be transforming data and so on. So you get these, and people do this because to use public blockchains in a properly decentralized way means that your dApp is usually slow, not performant, and so on. So people give in to the temptation rather easily. The exception to this, if you're accessing Ethereum particularly through a web browser, you might use the Web3 API, which is the application which interacts with the browser. It's the interface between the blockchain and your browser, and that means that because it's an open source project, you can have some trust in it. So this is the last slide. So this is basically the distinction, what it would look like. So with something that's properly decentralized, you would have a browser, Web3 interacting directly with the blockchain. Other public blockchains would have similar products which are being developed at the moment, but essentially anything that looks like this that's going through a centralized API. Okay, so it's great because it's probably slightly more trustworthy than something which is hosted in an entirely centralized way, because you can always re-engineer your application to access a public blockchain directly. But anything that has that degree of central control is probably slightly suspect. And when people say, we've built a decentralized application, hopefully you'll have a little more idea of what you should be looking for to see whether it really is.